Math 1314, Tyler Junior College, Section 3.6, Polynomial and Rational Inequalities. How to solve a rational inequality, example number 2. I think this last video will be sufficient, but as I've already mentioned to some people in the comments on some of my videos, if you are watching these videos and appreciate them, just leave me a comment. Let me know what's good, what could be better. And more importantly, if you're watching these videos to supplement a class that you are taking, and there is a particular problem or topic that I don't cover, shoot me a message. I'll be more than happy to make a video for you. Let's solve x plus 5 over x plus 8 is less than 2. I'm going to slightly alter the beginning of this problem. The main reason I'm doing it is in the class that I'm currently teaching, I noticed one of their online homework problems asked them for something that I haven't demonstrated yet. So what I'm about to show isn't critical to solving this problem, but for my students who are currently taking my class, I want them to be able to answer the question the homework asked them. In the very first video I mentioned that there were 4 versions of inequalities: a function greater than 0, a function less than 0, a function greater than or equal to 0, and a function less than or equal to 0. However, the inequality doesn't always have to have a 0 there. In some of the homework problems for the class I'm currently teaching, they ask you to first make the inequality have 0 because they ask you what function is over here. So for this one, before we make it say equal, I am going to not only get the 0 on the right side, but show you how you could put together the left side into a single expression. I don't know why I'm going to pause the video, I'm not done. So let's start this one a little bit differently by kind of starting to solve it by first getting 0 on the right side. Getting 0 on the right side is easy, just subtract 2 from both sides. So x plus 5 over x plus 8 minus 2 is on the left, whereas 0 would be on the right. I guess you could argue that, no, there's no guessing, this is a function. It's a function with a minus 2 on the end. I just don't know. I've got my classes online homework set up. I'm going to try to type exactly what I have written there and see if it's like, okay, that's fine. Of course, it's being stubborn. X plus 5 over x plus 8 minus 2. Although your answer is equal to the correct answer, it's not in the correct form. Even though I'm making these videos independent of online homework platforms or any particular book, things like that just drive me nuts. Your answer's right, but it's not the answer we're looking for. So for the benefit of my students, specifically for their homework, and for any student who wants to know how to combine these into a single fraction, it's not really as hard as it seems, because you know the rules for adding and subtracting fractions. Get a common denominator, combine the numerators. To get a common denominator here, we first need a denominator under the 2, and that denominator would be 1. So I'm going to invest some extra time in this video to review how to add and subtract rational expressions. If we put a 1 underneath the 2, make that 8 a little bit better looking. Then to get a common denominator, we can multiply both sides of this fraction by x plus 8. That will give us a common denominator of x plus 8, and now we can combine the numerators. The first numerator is x plus 5 minus 2 times x plus 8, and all this is still less than 0. We can clean up the numerator by distributing the negative 2 and combining like terms. Let's just do that verbally. Here's an x. If we distribute the negative 2, we have a negative 2x. X minus 2x is negative x. For the constants, here we have a plus 5. When we distribute the negative 2, we get negative 2 times positive 8, which is negative 16. 5 minus 16 is negative 11. So if you have a professor or online homework platform that is asking you what is the function you get if you put everything on one side, then it would be this. F of x equals negative x minus 11 over x plus 8. I'm pretty sure I popped it together correctly, but since I'm here, I might as well go ahead and just put that answer in and see. And by the way, if you're wondering what online homework platform I'm currently using in my classes, the answer is My Labs and Mastering, formerly known as My Math Lab, and it liked that answer. It didn't like this answer. Whatever. All right, so anyway, don't get me wrong, I don't have disdain for online homework platforms, but they're just computer programs and code, so they're gonna do what somebody else told them to do, not what I want them to do. Okay, so if for whatever reason you're being asked what is the function you are comparing to 0, and give me that function all nice and put together, it would look something like that. Now, all that said, I'm about to erase everything except the original problem, because in my personal opinion, everything that just happened here was unnecessary. I know. Besides, I could solve that last one the way we did in the previous video. So if you want to solve it using the version that I just erased, negative x minus 11 over x plus 8 is less than 0, go ahead. But I want to show you what I think is the most efficient approach, which is this. And it won't take that long. Number 1, pretend it says equals and solve. Because notice, we never solved anything yet. We just moved stuff around. If we put this equal instead of less than, you know what I'm going to say. If you're solving an equation with fractions, at some point, probably as soon as possible, multiply both sides by the denominator to cancel the fraction. Multiplying the left by x plus 8 would cancel the denominator and leave an x plus 5. Multiplying the right by x plus 8 would give me 2 times x plus 8. This is easy to solve. Distribute the 2 to get 2x plus 16. I got too many x's, so let's subtract the x on the left, because that will leave me a single x on the right. And since I'm trying to get the x by itself, let me get rid of the 16. 5 minus 16 is negative 11. So that is one of our boundary points, but it's not the only one. What is the other boundary point? Remember, in a rational inequality, the boundary points come from not only the solutions to the equation, but the values that make the denominator 0, and in this case it's negative 8. So I need to partition the number line at negative 11 and negative 8. Starting at negative infinity, which number would I run into first? Negative 11. Close that interval, open up the next one, negative 11, and then I would stop at negative 8, pretty close by. But once I cross the negative 8, I'm going to infinity, and there's my 3 intervals. And by the way, these inequalities can have 2 intervals or 1 interval. It's possible that the solution to the equation is not real, and therefore you would just take the entire number line, or more than 3 intervals, depending upon the size of the problem. I don't want you to think they all have 3 intervals. We need test values. To the left of negative 11, how about negative 12? Between negative 11 and negative 8, how about negative 10? And to the right of negative 8, how about 0? I will always pick 0 when the opportunity presents itself. Now, we test. Let's start with negative 12. At this point, I'm realizing there was a slight advantage to all the stuff I did before I erased. At the end, when we had negative x minus 11 over x plus 8 is less than 0, it's easier to compare to 0 than to 2, because to compare to 0, it's just a question of positive or negative. But I'm going to stick by my guns. If we substitute negative 12 into the original, we get negative 12 plus 5 over negative 12 plus 8, and we are comparing that to see if it is less than 2. The numerator is negative 7. The denominator is negative 4. I know this is positive. To compare it, you might want to get a decimal approximation. In this case, it is exactly 1.75. 1.75 is less than 2 is true. We keep the first interval. Now, let's test x equals negative 10. I had to look for my boundary points. Let's just verbally insert the negative 10. On the top, I get negative 10 plus 5, which is negative 5. On the bottom, I get negative 10 plus 8, which is negative 2. And I'm comparing that to see if it's less than 2. This will come out positive, but is 5/2 less than 2? 5 divided by 2 is 2.5. To say 2.5 is less than 2 is false. Don't need the middle interval. And lastly, we test x equals 0. This one should be pretty easy. We get 5/8, 5 on top, 8 on bottom. 5/8 is less than 1, so it's definitely less than 2. This is true. We keep u. And now we just have to put our intervals together with a union in between and decide whether or not we want to keep any of the boundary points. This is the easy case. The inequality said less than. It did not allow for it to be equal. So we don't keep the boundary points. We would never have kept the negative 8, but we also don't keep the negative 11. And so our solution is just the union of the intervals we kept. Negative infinity, negative 11, union negative 8, comma infinity. Quick follow-up, since this is the last video. What if it had said x plus 5 over x plus 8 is greater than or equal to 2? What changes would we make? Because it says greater than, all of these trues and falses would be reversed. Greater than would be false, greater than here would be true, greater than here would be false. So we would keep the interval that we threw away and throw away the intervals that we kept. So we would keep the middle interval from negative 11 to negative 8. But what about brackets and parentheses? The boundary point that came from the denominator, negative 8, is never kept. But the negative 11 is what made it equal. And if we allow it to be equal, then we would keep the negative 11. If you're doing problems like this on a homework assignment, I would practice in preparation for tests. When you solve one, ask yourself, what would the solution be if I changed this? What would it be if I put in or equal to? What would it be if I reversed it? What would it be if I did both? That way, you really start getting a deeper understanding about how all four of those varieties of inequalities work together. One last closing thought. This technique is not limited to polynomials and rational inequalities. This technique will work for practically any inequality. Now, we haven't gotten to logarithms and exponential functions, and this isn't a trigonometry class, so we don't talk about sine and cosine and tangent and things like that. But truth be known, this technique works for any inequality, provided two things. Number one, when you go to partition, you don't just partition the number line, you partition the domain. For example, there are some functions like this one, the square root of, let's say, x squared minus 4x plus 4, that's not a good one, is greater than 0. Because this, let's make it a little bit easier. Let's say square root of x minus 1 is greater than 2. I'm just trying to make up something here. Some equations have bigger domain issues than just take out a point or two, like take out negative 8. For example, the domain of this, without rehashing how to find the domain of a radical function, is bracket 1 comma infinity. So adjustment number one you have to make. When you partition, you actually partition the function's domain. You don't just automatically partition the whole number line. So you may have a smaller something in it that you partition. Thing number two. Actually, that's it. Yeah, that's it. The only difference between doing this technique for other types of inequalities is you may not start with the entire number line to begin with. So you start with the biggest domain you can, which in this case would be that, but then you do it like you normally do. You put it, you make it say equal, you solve it, you partition this. For example, if you solved this, you would get x equals 5. If you solve this equal to 0, square both sides, add 1. So when you partition the domain, you would go -1 comma 5 and 5 comma infinity. So that's really the only adjustment you have to make for this technique if you're solving other caliber inequalities. Make sure the domain is what you start with before you do any partitioning. Ooh, that was a long video, but I think it was worth it.